As autocrossers, we all want as much power as we can get. One of the things that can still power is the cooling fan. During an autocross run, you don't really need the cooling fan because you've got air flowing in. It actually draws a lot of current, maybe even up to 25 amps. So today's project is a little electrical mod that will help preserve our precious horsepower. This car has a manual switch to turn the fan off when you pull up to the start line. The problem with that is that then you might forget to turn it back on after completing your autocross run. So in that case, you're in a default dangerous situation for your engine if you happen to forget. So then this car has indicators and of course the temp gauge and the light that you really have to monitor. So the idea I had was, why not temporarily turn the fan off but have it come back on when a certain time expires. Now, autocross runs are 35 to 70 seconds. There's no reason why we couldn't maybe make a timer that delays the fan or pauses the fan for that amount of time, or maybe a little extra, and then resumes normal operation, factory temperature controlled operation after that. So I was browsing around the internet and I ran across a class of device called a timer relay. And this is a timer relay. What I wanted it to do is to cut off the power and be triggered by a button. This one here costs about $10 to $15. You can set it up for anywhere from 0.1 seconds to 400 days. It has a max current of 5 amps. 29 different time modes, and it's got a 30-page manual that you can download depending on how you want it to trigger. You can configure the time delays. Here you've got the timer. Your car battery would be here. You've got a button. Here is a relay which carries a higher load than what the timer supports, to be able to carry like 30 amps for my cooling fan. The output wire from the timer is, when the timer's active, it goes hot, it triggers the relay, and normally the 30 and the 87A are connected, and when the switch is triggered, the 30 and the 87 become connected. I don't care about the 87. I want to connect this up to the load, so that normally 30 and 87A are connected, but when I apply the voltage, they become disconnected, and that's going to interrupt my fan load. Red goes to positive, the black goes to ground. The green and white wires are for programming the mode. The blue wire goes to your button, and then the yellow wire goes to your output. The yellow wire is really what is going to control the relay. So this relay, it has a 40 amp capacity. What it does, it's a two-way switch basically, and normally the red and the yellow are connected. Now when you apply a positive voltage to the white wire, then the red and the blue become connected, and the yellow is no longer connected to red. I don't really care about the blue wire. It's not going to connect to anything. What I care about is whether the yellow and red are connected. Now this is normally closed, meaning current is normally going to flow until I put a positive voltage on this white wire. And this will be the wire that the timer controls. Now, it doesn't require a lot of current to trigger this thing. Got this waterproof button that is going to trigger the timer relay. And it's got a nice little LED light around the outside of it. And I'm going to hook up the light to the output of the timer so that whenever the timer is active, it's going to light up. So putting it all together, with everything kind of schematically taped together, we've got the button here. This brown is unused. It's normally closed. We don't need that. We want the normally open wire, which is the blue wire, to connect to the timer trigger. The other side of that is connecting to ground. So this will be, the white and the black will be grounded. And this red wire here is for the LED to get the output, to show when the output is high from the timer. On the timer side, this one is going to be basically the ignition accessory. So when you have the key on or the ignition on, this will be hot. This goes to ground. Got the output going to the relay, the white of the relay. Blue is unused, ground, and then the fan wires will connect, or the fan wire will connect up to the red and the yellow. I chose timer mode 23, button interface with timeout. This shows 3 different scenarios. If you push the button, it's going to trigger it momentarily. The timer remains active for the configured timeout, and then it goes inactive. You can also trigger it momentarily and then turn it off before the time expires if you want. Or the third mode is if you push the button down for a long press, it will activate the timer only when you're holding it down. I chose to put the timer basically right next to the button on the back side because it simplifies the wiring going out. All I have is power, ground, and the timer output wire, which is the only wire that needs to go through the firewall. The button is installed. It's not connected to anything except for the LED light that's in here. I want to show that the timer is working, just the output. I'm going to turn on the ignition. It'll be a bit noisy because I think it's a pump that runs when I turn it on. But then I'm going to turn this on and then toggle it back off. I'm not going to wait for the 80-second timer. Testing the fan relay to make sure it's normally closed. Now I'm going to push the button. Nothing. That's what we want. I'm going to push it again to deactivate it. Now it's closed again.